All right, welcome to today's video, video 4 of Unit 6. Today we are going to be proving quadrilaterals, which means that we are going to be looking at different four-sided figures and trying to verify, given the properties we observe, what kind of four-sided figure is it? Is it a trapezoid? Is it a parallelogram? Is it a rectangle? And so on. There's not any glossary entries for today. There are a few words that you'll need to know, but we've kind of already talked about them in our properties of quadrilaterals table that we did on Monday. So you can go ahead and turn in your packet to page 9. It should look like this. It says Proving Quadrilaterals. And we're going to start out by taking just a few notes. So we kind of foreshadowed this already when we were talking about the properties of quadrilaterals, but there are 2 or 3 basic things that we have to make sure we check for. First, we need to know the length of each side so that we can verify whether different sides are congruent or not. We also need to know the slope of the different sides of our quadrilateral because we need to know if opposite sides are parallel, and we need to check for right angles, which would mean that adjacent sides are perpendicular. So the first thing with each problem that we're going to do is look for congruent sides. We do this using our distance formula. And if you need a refresher on distance formula, you can go back to video 1 and see some examples of that worked out. And then the next thing we're going to do is look at the slopes. If opposite sides are parallel, then their slopes are going to be the same. We also need to check for right angles. To do this, we're going to look at the slope of each line, and slopes that are negative reciprocals make right angles. And what a negative reciprocal means, in case you don't remember, is, for example, if I had a slope of 1/2 on one line, then if it makes a 90-degree angle, the adjacent line would have a slope of -2/1 because I would flip that slope and change the sign of it. All right, so let's go ahead and dive into an example. For example 1, you're going to first need to plot these 4 coordinates for this quadrilateral. I would recommend labeling those points as you plot them because it'll make it easier when we start referring back to line segments and things if you've got the labels there. So C is -4, 3, and D is -6, -1. Okay, I'm going to use my straight edge to connect it so that I can really see this quadrilateral here. And now I'm going to start trying to figure out what kind of shape it is. Now, when you first look at it, it looks like maybe it could be a trapezoid because in a trapezoid we have one set of parallel lines. So when I look at this, I think, maybe this DB and AC might be parallel, but it's hard to really tell. So what we're going to be using to help us prove these quadrilaterals is a little table that looks like this. The first thing you're going to need are the different sides, and we name line segments by their endpoints. So this side is going to be AC. I'm putting it towards the bottom because I'm going to need this space up here in just a minute. So the endpoints for AC are A is -9, 2, and C is -4, 3. And I'm just putting those there for ease of reference because they're going to be useful when I move into my distance and slope formulas in a moment. Okay, then I'm going to go to this side, which is CB. And my point for C is -4, 3. My point for B is 7, 2. Okay, and then I'm going DB, or you can put BD. The order doesn't really matter as long as you've got the same 2 endpoints, and that is going to be 7, 2, and D is -6, -1. Okay, and then the last line segment is AD. So line segment AD has the ordered pair -9, 2, and then D is -6, -1. Okay, so if I'm going to prove what kind of quadrilateral this is, I am going to need the distance of each of these, which means I'm going to need the length of each of these line segments, and I'm going to need to know the slope. So remember your distance formula, I'm just going to write up here, is x x2 minus x1 squared plus y2 minus y1 squared. I ran out of room a little bit there. And then my slope formula is y2 minus y1 over x2 minus x1. So this is the formula I'm going to be using right through here. So 4 different sides, and then I'm going to use this formula down through here. Okay? So what I'm going to do now, I'm going to work through the first distance and the first slope with you just so you can kind of see how it goes, and then I'll let you work out the rest on your own. Okay, so this one, x2 is -4 minus -9 is going to be squared, plus, and then I'm getting my y values, 3 minus 2 squared. Okay? Let me zoom into that for you a little bit. All right, then -4 minus -9 is, 5, because I would change that to adding. So it becomes 5 squared, and then 3 minus 2 is 1 squared. All right, following through with those order of operations, 5 squared is 25, and 1 squared is 1, and then I get the square root of 26, which is approximately, and you would pull out your calculator for this part, but when you put that in the calculator, you get square root of 26 is approximately 5.1. Can round that up, and we get about 5.1. Okay, so that's the distance formula, and you are going to, if you you're going to do that same step for each of these line segments. All right, let's go ahead and do the slope on this one first. y2 minus y1 means I am taking my y values, so it's going to be 3 minus 2 over my x values, so -4 minus -9. Notice that if you set it up this way, then my y subtraction is the same as it was over here in my distance formula. My x subtraction is the same as it was over here in the distance formula. So you can kind of help yourself out a little bit there. 3 minus 2 is 1. -4 minus -9 is 5. So then my slope for this line is 1 over 5. All right, go ahead and pause the video and finish up the rest of these, and I'll check back with you in just a moment. All right, so you can check your answers against what I did. If you have any questions, be prepared to ask for them in class tomorrow, but this is the distance. So line segment CB is 11 units long. Line segment DB is about 13.3, and then AD is about 4.2. So what that tells me then is none of these values are the same. So I can say that I have no congruent sides. So when I'm trying to decide what kind of shape this is, none of the ones that have congruent sides are going to apply. So parallelograms are out because opposite sides are congruent. Rectangles are out for the same reason. Rhombus and square is out because that should have all the sides congruent. So that leaves me with just maybe a trapezoid, which is what we kind of were thinking ahead of time. But also, if you have a trapezoid, you should have exactly one pair of congruent sides. Well, of sides with the same slope that are parallel. So when I look over here at the slopes, I've got 1/5, I've got -1/11, I've got 3/13, and I've got -1. None of my slopes are the same, which means that none of these side lengths are perfectly parallel. So I can also say that I have no parallel lines, which means the only kind of quadrilateral this is just that, a quadrilateral. It doesn't fit any of the properties needed for any of the other problems. All right, if you have any questions, be sure to bring them to class tomorrow, and we will see you in class.